Hi and welcome to Terranet's 2025 AGM. My name is Lars Lindell, I'm the CEO of Terranet, and I will do this presentation together with Pierre Ekwall, who is our CTO. What we will talk about is our system called Blink Vision, but it is next generation of anti-collision systems. For the agenda, we will give a brief introduction to Terranet for the people who have not followed the company before, and we will do a brief market overview. We'll talk about what makes our technology unique and then give some highlights of what we accomplished during 2024, but also for the first part of 2025. And then finally, talk a little bit about the future. One of the figures that we work with is every year, according to the World Health Organization, 1.90 million people dies in traffic. But that's not all. Somewhere between 20 to 50 million people become severely injured. And that makes a cost to society of about $8 billion every day. So improving this technology is vital to reduce the suffering and the costs associated to traffic accidents. And that's where we work. Out of these 1.90 million, more than 50% of the accidents are with what they call vulnerable road users. And that's basically pedestrians, people on bikes, people on scooters. People are very unprotected in the traffic environment. There are already technologies, and ADAS is such a technology, but why doesn't it prevent all accidents? Well, one of them is sudden appearance. A child coming out from behind a car, everything happens very fast. Lighting conditions can be less than optimal. Very complex traffic situation makes it hard for systems to understand what is really happening. The systems are limited in terms of vision, but also speed. And then false interventions. Some people actually disable the ADAS systems because they think it's irritating when someone else takes the braking decisions than themselves. So there's a lot of limitations to today's ADAS systems, and that's what we want to improve on. A little bit about Terranet. We are a Lund company in Sweden, headquartered in Lund, but we also have offices in Gothenburg and in Stuttgart in Germany. We are 22 people and expanding. We are hiring more engineers. Market cap around 120 million Swedish crowns. The company was founded in 2007 and was listed on the stock market in 2017. What we develop is a system called Blink Vision, and it basically consists of three different parts. One is a laser scanner that scans the environment. Then we work with event cameras, and event cameras are different to normal cameras in the way that they only work in the same way as a human eye. They only work on changes in the environment rather than taking full pictures. And then basically we do a software which we call the perception stack, and that is basically an AI-trained software that basically classify the object. Is it a human? Is it someone on a bike? Is it a football? Or what type of object is it? And where is it in 3D? And in what direction is it going with what speed? So that software we develop, but it's placed on a normal computing unit within the car. And the promise of our technology is that we will be able to react and take a braking decision 10 times faster than the existing ADAS systems. So that's, as I explained before, will make huge savings to society. Our market is a market that's driven by regulation, of course. In Europe, there is an organization called Euro NCAP that basically sets the standards to which the car manufacturers are tested. And for the 2026 standard and 2029 standard, basically there are a few areas that are prioritized. And those are vulnerable road users, as I explained before. They want faster systems. They want more robust performance. And they want systems that can cover more complex traffic situations, all areas where BlincVision excels. Yeah, so basically our system, BlincVision, are basically targeting two markets. One is autonomous driving market, which is already today a quite big market. It's 1.9 billion, but it's expected to grow very fast during the next few years, and one of the fastest growing segments within automotive. We're also targeting ADAS systems, which are basically systems that helps the driver of driving better. It's already a very big market, 40 billion, and it also expected to grow very fast in the users. So both of the markets, very big and expected to grow very fast. The way we fit into the industry is that you of course have the normal car brands such as Volvo, BMW, Volkswagen, Tesla. Those will probably not be our direct customers, even though we talk a lot to them. But between us and the car OEMs, there will be what they call first tier, and that is companies that basically take technology and create systems and integrate those systems into vehicles. There are basically three types of companies working with autonomous driving or ADAS systems. There are purely camera-based companies. There are companies who work with LiDAR or radar, and then basically there are companies that work with a combination of lasers and cameras, and we at Terranet are one of the companies work with a combination of these technologies. This technology, of course, can be applied to other industries. So today, BlincVision is very focused on autonomous driving, but also on ADAS. But we of course see ways that we can apply the same technology to many other industries. An example of those industries can be agriculture, it can be drones for military, it can be robots, and it can be logistics. Anything that wants to classify an object and basically respond very, very fast to what that object is doing. So we will explore other industries as well once we have launched BlincVision. So with that, I will introduce my colleague here, Pierre, who will explain what makes our technology unique. So welcome, Pierre.
Thank you, Lars. So my name is Pierre Ekwall. I will talk a little bit more about the technology and also what it is that makes BlincVision unique. So we talked a lot about BlincVision. It's designed to be the fastest anti-collision system for road traffic. But how does it really work? So I try to break that down into the main 5 operational stages of the system. First off, we have the scene illumination. BlincVision scans the scene with an infrared laser scanner up to 35 meters. And you might wonder, why is the range set to 35 meters? Why not 45? Why not 25 meters? So 35 meters is actually set because it correlates to the distance you need to be able to drive a vehicle at 70 kilometers an hour. Usually the highest speed you'll see a vehicle driving in urban environments. So we thereby, by design, eliminate anything that's further away, minimizing the data flow to our system and thereby reducing latency of the calculations we need to do. The reflections are then captured in the second step. We have reflections back to the event camera. And for those of you who haven't heard about event cameras before, it's quite a unique technology, and it has a lot of impact on how BlincVision actually can perform. So the event camera differs from an ordinary RGB camera in that an RGB camera captures color information, which we do not capture with the event camera. We don't need it. So we reduce some data already there. Also, the event camera has the unique capability of identifying contrast differences. So it only reacts when you have a contrast difference, and that means when something is actually moving in the image. So you will only get data outputted from the camera on movement, more or less, compared to an ordinary RGB camera that will send you a number of complete pictures, frames per second, just bombarding the computer overloading the processor. So with an event camera, you get much less data, and you actually get a lot less latency. Because instead of send a complete picture or scene representation, we can actually send the actual events themselves when they happen with microsecond delays only. So that's quite unique. And they will output the data pixel by pixel, much like the human eyes and brain. The third step is mapping the environment. So we take the image received by the left and right event camera and combine them. And when we do that, we also eliminate all the noise in between the two images. We combine that into a 3D representation of the scene. The 3D representation will then also contain depth information. Much like the human being having two eyes to be able to see depth, we do the same with event cameras. We use two. That means we can measure the distance to objects, which is, of course, very important for an anti-collision system. After mapping the environment, we move over to object classification. In object classification, we pick out the different objects that are visible in the scene. We also calculate the velocity on all of those objects to be able to see how they move. And that's used in the next and last step, the decision making. So we use the objects and their velocities and compare them to the vehicle's velocity and trajectory and see if we will have an intersect. And if we will, that means we could have a collision, right? And if we foresee that we can have a collision based on the different velocities of the objects, we generate an automatic emergency brake request to the vehicle, who then directly initiate full braking power to avoid an accident. Another benefit of the extreme low latency that BlincVision has, I mean, the first one is, of course, that since we have low latency, we can detect if something that is an obscured object, an obscured pedestrian, for example, somebody standing behind a vehicle or behind a bus, steps out into the road, then you need to react extremely quickly. You need low latency. So that's one of the main benefits. Another benefit, a side effect of this, is that since we are so quick in detecting the objects and being able to brake, that means we can actually allow ourselves to wait usually longer. If we have enough distance to the object, we can wait longer than other systems. And this enables us, since we can wait longer, to do more analysis, and that thereby reducing the false interventions that are so common for the other systems, and that Lars talked about earlier, makes some users actually deactivate their ADAS systems today. So that's a very important side benefit of BlincVision. Okay, moving over to the highlights. If we look at what we did last year, it was a very important year for Terranet. We had some really great momentum. We started with the demonstrations in lab environment already in Q1, and then quickly moved over to vehicle integration and vehicle testing in Q2. In Q2, we did all the testing that's of course necessary to test the system in a vehicle. We were able to identify how the system would work with vibrations, how it would work at different speeds, and we were also able to generate the brake request to be able to analyze how quick the system could be in real life. An important factor though was that we did not actually brake the vehicle. So we did use the analyzed data to be able to see how quick we could be, but this was in theory. In Q3, we had a very important milestone, and that was the first time we actually did our first autonomous braking, where we did end-to-end testing at a Euro NCAP certified test track, proving not only that we could do this in theory very, very quickly with low latency, but that we could be up to 10 times faster in real life, actually from being able to detect the pedestrian to actually initiate braking and to be able to do that without colliding with object. So very, very important milestone. And in Q4, we signed a partnership with an OEM/Tier 1 for actual customer evaluation of our system to give further input for the future development of the MVP. Some other important milestones for 24 was we were selected to be part of the Verdas project, where together with global players, where we can interact and impact the Euro NCAP requirements going forward, raising the bar for what ADAS systems actually can be assumed to deliver. We were selected by the accelerated program Mobility X Lab, as you know, which then later led to the cooperation with the Tier 1 OEM partner end of the year. We defined the roadmap for 2025 and also signed a very important agreement with an automotive player within the mining industry, which I'll talk a little bit more about for 2025 in the upcoming slides. I'd also like to show you a short video clip of something we're very proud of, as I mentioned, the first autonomous braking in a real live environment at Asta Zero, a certified Euro NCAP testing ground. And please pay attention to the last seconds of the video where you will actually see the vehicle braking and avoiding an accident.
Welcome to Asta Zero. This is a Euro NCAP certified test site for future road safety. What makes this site unique is its ability to test a wide range of traffic situations. BlincVision's unique combination of event cameras and AI development models requires a large amount of training data from various traffic environments and scenarios. As you can imagine, this site offers all the opportunities we need to evaluate and improve our system.
Yes. So there you have it, the first autonomous braking law done last year, Q3. Okay, moving over to the key activities for 2025. So as I mentioned, in Q4 last year, we started the proof of concept with a partner, and in Q1, we finalized the report of the conclusions from that testing, giving us very valuable information about how to improve on the product. We also initiated the next customer project with the mining industry partner, which is also a very important step for 2025. We were also working with the requirements for the MVP and doing concept selection and concept evaluation for the upcoming MVP design during Q1. And now in Q2, we have started the development based on those requirements and the concept selection we did in Q1, developing the next generation of BlincVision, the MVP. This MVP will then, during Q3 and Q4, be evaluated by different customers to be able to get feedback on the system performance and how our customers think they best can make use of our low latency technology. Something we're looking forward to very, very much, the customer dialogues generated from this. And in the end, this is what we plan to lead to a signed contract with one of these partners, initiating the initial dialogues towards volume production. So you might wonder, what is the MVP and how will it be packaged? What will the customers actually receive and be able to test? So the delivery content of the MVP package will consist of our sensor system, which is completely contained in a roof rack mountable system, which will be IP classified. It will also contain a laptop with all the needed tools to be able to run, start, and shut down the system. We will include perception visualization software that enables the customers to see exactly what BlincVision sees and to understand the benefits. We will include an interface software which makes it possible for the customer to connect our system to their vehicle and braking system, so that when BlincVision generates an automatic brake, that the vehicle actually can trigger on that and trigger the brakes. Another part of the interface software is that we will also provide a point cloud, so data output from our system to the customer, so that they will be able to use our output in conjunction with their sensor fusion systems to evaluate how BlincVision can be used in conjunction with their already existing systems. And last but not least, we will also have a setup and operations manual sent with the product. And this is to be able to disconnect the Terranet completely from needing to be on site when the customer uses the product. So no need for any Terranet engineers or any Terranet support during the evaluation. Can be used completely standalone. And what will be evaluated? Of course, all our customers will have their own view of what they want to evaluate. And that's good, because that will probably differ a lot between the different customers, something we like. We want differentiated input. But also we want to make sure that the most important aspects and unique selling points of BlincVision is understood. So therefore we have prepared a couple of test cases that showcases the benefits of BlincVision to the customer that we really want them to test. Some of them are focusing on the sensor level, sensor system level, which means we are in the first showcasing test showing our ultra-low latency data output, where the customer will be able to receive extremely high speed, low latency, constant data output to be able to see how quickly we can generate data. In the next sensor system level test, we will have ultra-fast scene representation shown. And this means not only delivering data in a stream, but actually be able to deliver a complete scene over and over and over again at extreme low latency and very high speeds, much quicker than any other ADAS systems currently available on the market today. And that's on the sensor level. Then we move over to the application level, where we actually add our perception software to the test. So in the first of these two tests, we will use the output from the ultra-fast scene representation, take those scenes, but also do object detection in those scenes, being able to pick out any object and classify them in the scene with ultra-low latency, of course. And in the last test, we will add a complete anti-collision detection software, where we'll not only pick out the objects, we will do the rest as well, as mentioned in the earlier presentation, where we look at the velocity of the object, the class of the object, the vehicle speed, and initiate a brake request. And showcasing these 4 areas, 2 on the sensor system level, 2 on the application level, ensures that the customers will understand unique selling points before they start doing their own testing, which we think is very valuable. With that, I think I'll hand over the word to Lars for some wrap-up of our next steps and potentials in the future investment in Terranet. So Lars, please take over.
So, thank you, Pierre.
Thank you, Lars.
So I will just do a wrap-up of this presentation. As Pierre presented, 2025 will for sure be a very, very interesting year. It is actually the year where we will launch the MVP and get that to market and get the feedback from the customers. In parallel with that, we will of course enhance the product, but we will also start the discussions on new application areas. Finally, once customers have evaluated the MVP, what we want is really to sit down with them and discuss how we're going to industrialize this product and how can we come to volume production. So that's basically the whole goal, and as Pierre has said, we are very focused on getting the MVP to market as soon as possible, because that is a start of the commercial journey. Finally, why should anyone invest in Terranet? Well, as I think we have demonstrated with this presentation, we do have a unique and very competitive product on the way. We are in an industry that for sure will grow. I'm very much of the opinion that in the future, anything that can be driven better by a computer than a human will be driven by computers. And that's where we are. And finally, but very important, is that making it a safer world and saving people's lives. So with that, thank you very much from us here at Terranet, and hope to see you in the future.